For example 5, yes, you are going to copy this down in your Cornell notes. We are going to graph another quadratic function. Here's a tip just to remember. When we are looking for points that are on opposite sides of the axis of symmetry, not only are the points equidistant, which means equal distance from the axis of symmetry, they are also equidistant from the vertex. Okay, so we'll talk more about a little about that later when we get into the actual example. But let's start. It says graph the function f of x equals x squared plus 4x plus 3. So the first thing we need to find is our axis of symmetry. So we're going to use a, b, and c from the actual equation. So here, a is 1, b is 4, and c is 3. We're going to plug them into our equation, and once we plug those in, we get x equals negative 2. So now that we know that x equals negative 2, we're going to plug negative 2 back into our equation to figure out what y is. So when we plug negative 2 back into our original equation, we get that y is equal to 1. Negative 1, actually. So we have our x value, we have our y value, so we have our vertex. Our vertex is at negative 2, comma, negative 1. And if we look back at our example problem, because a is positive, the graph opens up. So that means that the vertex is a minimum. So step 3, find our y-intercept. Remember, y-intercept happens when x is equal to 0. So all we're going to do is plug 0 back into our original equation. When we plug 0 back into our original equation, we get y-intercept happens at 3. So now, looking back at all of the information that we've just collected, we know that our vertex happens at negative 2, comma, negative 1. And because a is positive, we know that our graph opens upwards, which means our graph has a minimum value. We also know that our y-intercept is at 3. Because we have our vertex, we also have our axis of symmetry, which happens at negative 2. So our axis of symmetry happens at negative 2 because our axis of symmetry is the x value of our vertex. So now, we can take what we have and we can use our graph. We can use a graph to graph it. So looking here, we said that our vertex happens at negative 2, comma, 1. So here's our origin here. Our vertex happens at negative 2, comma, 1, negative 1. So that's our vertex there. I'm going to try to put a point over that so you can see it. That's the vertex. That's the first point we started with. And because we know that that is our vertex, we know that that red line there is our axis of symmetry. That's the line that's going to cut our parabola in half. We know that our y-intercept happens at 3. So we know that we cross this y-axis here at 3. And just like that tip just said, our points are going to be equal distance from our axis of symmetry and from our vertex. So here, this point is 2 units over from our axis of symmetry. So that means that 2 units to the, well, our point was 2 units to the right of the axis of symmetry. So 2 units to the left of the axis of symmetry, there needs to be a point as well. So that's how we got these 2 points here. These 2 points here are our zeros of our equation. And we get that straight from our equation. And once again, we're going to go over factoring again, but that's what we were factoring for. When we factor that out, we know that our solutions or that our roots of that equations happens there, 1 unit away from the axis of symmetry. So once you connect those points, and remember, you only need 3 points. So we had our vertex, we have our y-intercept, and all we need to do is put another point equal distance from that axis of symmetry, and we have our 3 points. Connect your 3 points, and that's your parabola. We are not going to do the guided practice for this example, but what I do want you to copy down in your Cornell notes is this here. I want you to copy down the top part of this chart. So these top 3 rows of this chart. It's talking about linear functions, exponential functions, and quadratic functions. We have not gotten to exponential functions yet. We have covered linear functions though. And we know that y equals mx plus b is slope-intercept form. M stands for slope, b stands for y-intercept. The degree of a linear function is 1 because this x is to the power of 1. And when we graph a linear function, it's going to look like a straight line. Not that kind of straight line, but a real straight line. We also are going to cover exponential functions. I know we haven't gotten there yet, but the equation for exponential functions is y equals a times b raised to the x power. The degree is the x power. And exponential functions actually look like a curve, which is actually what it looks like right here. But yes, an exponential function looks like a curve, more so. And this is really supposed to be a straight line. Quadratic functions have the equation y equals ax squared plus bx plus c. And remember, a cannot equal 0. And the reason a cannot equal 0 is because if a was 0 right here, anything times 0 is 0. So this entire term right here would go away, which means that it would be a linear function again because now it's degree of 1. So that's why quadratic functions, it always says that a cannot equal 0, because if a was 0, we would just have a linear function. So that's the thing about quadratic equations. Quadratic equations have a degree of 2, which creates that parabola, which looks like the U shape. So this top part of this chart here, these first 3 lines here, is what I want you to copy down in your notes. Watch the next video for the next example.